toolkit functions y equals x squared. That would work if I'm at work abstraction. Next, knows what. After vertical stretch, after A, okay, vertical stretch factor A, vertical and horizontal shifts, horizontal and vertical shifts H and K, we get a new function. I'll call it U X equals A times F of X minus H plus K. Something you need to have pretty much completely mastered for this test and did the homework on a few weeks ago, okay? With function notation and transformations in chapter 1, okay? Well, that equals A times X minus H squared plus K. All right. And if you know what A, H, and K are, you got numbers here. We'll do something with numbers shortly. There it is. That is your general quadratic function. Every quadratic function has that form. And this form, and we didn't do this in MDE 61, but you'll see it in the assignment. This is a vertex form. Vertex form of any quadratic function. Where's the vertex? Well, the vertex of your toolkit function is at the origin. Where does the origin go under these transformations? If you vertically stretch the thing, that doesn't affect the origin. The origin has zero distance from the x-axis. You vertically stretch the whole thing, but the origin, the vertex stays where it is. If the first thing you do is to vertical stretch. And that has to be the first thing because multiplication means addition and subtraction. Okay, so vertex form of any quadratic function. What's the vertex? Well, where does the origin go? The origin goes to the point HK. You should be familiar with that because that's what we've been doing over months now. Okay. Horizontal sheet H. Vertex of the origin to the point HK. Now that's exactly what we've been doing. I give you a quadratic function. Well, I say construct a quadratic shape in a 4x4 box. Move the red dot to the point HK. The red dot is the vertex for your toolkit function. You move it to the point HK, then that's where the vertex is. And that graph is the graph of your shifted function. Now, I haven't been doing a lot with vertical stretch because I want you to understand the shifts. But you could first vertically stretch it. The origin, the vertex stays at the origin. Then you move everything H units this way, K units this way, and your vertex is at the point HK. You should be very, very clear about that after all we've done. Connect that with what we've done with the constructions. Think about it. You think about it when you do the constructions. Okay. Now, what's a vertex form? If you vertically stretch it by factor 5, shift it horizontally 4 units, and vertically shift it 6 units. What would it be? Well, right there is a vertex form. So tell me what the function would be. Write it down. And don't write down the rest of the words that you see on the board until you do that. You can leave yourself room to write them, but show me what the vertex form is. We want the vertex form, not the coordinates of the vertex. The vertex is at the point 4, 6. So if you wrote that down, that's good. And it's not exactly what we wanted to do, but what we want to do is very simple. Right here is the vertex form. Okay, vertex form. This. So you kind of want to focus on that. So it's easy. I told you what the vertical stretch factor is. Well, that's A. Okay, well, the vertical stretch is 5. Horizontal shift is 4. Vertical shift is 6. Okay. So I just told you what the numbers were to put into this vertex form. So focus on that. If you didn't get it, it's easy. But you might want to go back, look at my explanation again, or see what the math tells you about it. Because they'll tell you right away. Okay. I mean, yeah, everything they tell you is right. I don't necessarily always agree. It's a good idea to approach it the way they do. But they probably think what I'm doing isn't right. Okay, isn't the best way. So one of us is right, and I don't know. Okay, so why is this? Okay, well, that's pretty easy, isn't it? Okay, now. Adding this. Square x minus 4, you get x squared minus 8x plus 16. If you don't understand that, email me and I'll give you some references. Just x minus 4 times x minus 4 using the distributive law. Okay. And if you don't understand it, look at the MD 61 video where I addressed the expansion, did it in detail. Okay. Not going to do it here because you need to know that in the algebra. I know that not everybody is comfortable with that, but be comfortable with the idea that you can look at the MD 61 video and see the time in detail. So anyhow, we do this, and then we distribute 5 through here. We get 5x minus 40x plus 80 plus 6, which is 5x squared minus 40x plus 86. If I did all my algebra correctly. And this is just straightforward algebra. Boom, boom, boom. You do it. And if you don't understand that algebra, you're going to have to spend some time doing examples. So email me if you want examples. Tell me how many you want, 10,000, 20,000. Okay. Takes me probably 20 minutes from scratch to write out the code for a set of problems, run it, send it to you. Okay. I don't mind doing that at all if you're going to use it. I'm not going to use it, I'm not going to bother. There are other things that can benefit you more. Things you're not going to use. Okay. And that's what I want to be doing. Okay. But if you're going to use it, ask me. Consider examples and solutions. Or you can go online and find them anywhere. Okay. Google expanding the vertex form of the quadratic function. You get 78 million hits. All right. So anyway, there it's expanded. Now, again, in the vertex form, you can read off the vertical stretch in the coordinates of the vertex, right? Vertex is at 4, 6. And you vertically stretch it 5 units before you move it over there. And again, I drew pictures in the NDE 61. You gotta see the old math. But if you're having trouble retaining and understanding it, look at that NDE 61 thing. I'm assuming I'm going to be able to post the thing. Yesterday I recorded some stuff, but I couldn't access, the internet thing, which stuff to post yesterday. So. Okay. I should get it all posted today. Okay, so we get this. So picture of that. I just wrote down that this is vertically stretched. My factor product should be stretched. Horizontally shifted 4 units, vertically shifted 6. What's that mean is you have the original function. And you could do it in a 4x4 box if you want. Okay. In matter of fact, in this course, we do it in a box. Now you got to vertically stretch it. Okay, so you got the 4x4 box, right down at the origin. Then you vertically stretch it. What does that do? Your 4x4 box becomes 20x4. And you subdivide the box just as you always do. Long skinny box, you can subdivide it, and you can get a picture of your quadratic function. This function is y equals x squared. This function is y equals 5x. For any x, the y coordinate is 5 times as high as on this graph. Okay, every point moves 5 times further from the x-axis. It doesn't quite look like that the way I drew it because I didn't do all the subdivision and everything I need to do. But there it is. Then what do? We shift it horizontally 4 units. Okay, well, you know, the 4x4 box, so here's where x equals 2. We're going to shift it. Well, here's 4 units. Okay, we shift the every point 4 units, and in particular, we're going to shift the origin 4 units. Okay. Now here's 4 units of y. We've got to shift 6 units, which would be about this way. So we're going to shift it about here. Here's the new vertex. We sketch a 4x4 box here, our 20x4 box. We construct graph within that box. Okay. So here's our 4x20 box. Yeah, it's 6 units higher, so it goes all the way up to here. That's like 4x20, it's 20x4. Again, the red dot is at the vertex, and it's the vertex that we've moved here, so the vertex is going to be here. And now we sketch, you know, subdivided again. So you got to go through each point. Okay, let's see. Okay. So this is the function. All right, here, we can do estimates. We can compare the estimates with what the function tells us, and they're going to work out. That's the primary thing I want you to understand on those high point problems. They're going to be in the test. And they're already there on your set problems. Okay. And I've addressed in minute detail on like 7 hours of video. It took me a while to make. Okay. But you can see the details at 4 different levels as I expect, as I explained. See it in print, but without all the words that I use in the long version. Okay. See a shorter synopsis and a somewhat longer synopsis and the whole thing. Whatever you need, for whatever problem, you should be able to find it pretty easy. Okay. Now, again, there it is. That should all be pulling together. Now, the plan was you would have finished the test by today. Okay. So you would have pulled it together. So this would make a lot more sense than it probably does after the official disaster of the last week. The disaster center still set up the Main Street. Now, I don't know. But it's regional. 7 inches of rain, then the hurricane dropped a couple more and got windy. It was a mess. Fortunately, I haven't heard if anybody died. This we Damascus started 6 feet of water. People survived. That got a mess. But they survived. Anybody from Damascus? No, I expect to see a lot of people from Damascus here because you still can't get in town. There aren't many alternative routes. Okay. Well, that's great, but how do you get from this form to this form? It's easy to get from this form to this form. You just expand things, right? How would I know that this equation gives us this set of transformations if I didn't already know? Well, I know. Okay, you got y equals x squared plus px plus c. What you have here for a is 5b equals negative 40, c equals 86. But for any quadratic function, your axis of symmetry is the line, vertical line. Remember, I've had you label your construction lines. The vertical lines are labeled with x coordinates because x is the same everywhere on a vertical line. The horizontal lines are labeled with y coordinates because y is the same on every horizontal line. I hope that you've locked that in, but my experience is that students are slow to lock that in, even though we've been doing it for weeks and you've been asked to do it in class and for homework. Okay, somehow not locking, some of you are probably not locking it in as well as you might. Some of you probably haven't locked in total. Okay, if it's not locked in, ask yourself, what can you do differently when you're learning this stuff to lock these things in so you don't trip over them when you need them? Okay, so one thing that people are going to trip over is the fact that this axis of symmetry is a vertical line and has support. It's an x equals line. In this case, it's x equals negative b divided by 2a. All right. Whatever a and b are, this tells you where the axis of symmetry is. So your picture is axis of symmetry someplace. Now that's not this function. The axis of symmetry for this function is this first line you make when you start dividing the thing with vertical lines, the one in the center of the box. Axis of symmetry is x equals 4. If you divide b, which is negative 40, by a, which is 5, you get negative 8. If you divide it by 2 times 5, which is what this says, in other words, b is negative 40 and a is 5, this gives you negative 40 over 10, which is negative 4. Then you've got a negative out front, which gives you the positive 4, and there's your axis of symmetry. So we worked that out in detail in MDE 61. Okay, so you need to see the details. That's what they'll do. And it's kind of a neat discovery because I had people plug these numbers in and they said, aha, same thing we got here. There's the axis of symmetry. That should reinforce the idea of the axis of symmetry. And what is an axis of symmetry? Well, in chapter 1, you learned about right left symmetry. This thing is symmetric about the y-axis, the toolkit function. This goes vertically stretching toolkit function. Then when you move it, the axis of symmetry moves along, still right down the center of the box, right through vertex, right? And we're symmetric about the vertex. What's on the right is a mirror image, what's on the left, and vice versa. All right. So anyhow, you have an axis of symmetry. This is for any, okay? Okay. You have the axis of symmetry. Vertex is on this vertical line. Okay. One part of the vertex. You plug the x coordinate into this function, whatever the numbers a, b, and c happen to be. You know the numbers a, b, and c. You put those numbers into this. Tells you where the vertex is. It tells you where the axis of symmetry is. You plug in the coordinates of the axis of symmetry into this, and you get the y coordinate of the vertex. Okay. So now, so here's your y coordinate. The y coordinate is value y to this horizontal line. So here's your vertex. Well, now you know what h and k are. H is whatever takes you from here to here, right? Well, the negative of what takes you from here to here. And k is whatever takes you from here to here. You'll know these numbers. Then you have your vertical stretch, which determines how skinny the parabola is. You can also determine y-intercept. X equals 0. Okay. In other words, you plug in x equals 0, and what you get is really easy. It's whatever that number c is, right? Because 0 squared is 0. B times 0 is 0. All this is 0, just like with this. So, for example, here, your y-intercept would be at 0.86. Well, 20 is here. And see, this thing hasn't gotten all that close to the y-axis yet. It has to go up a lot higher before it hits the y-axis. It makes perfect sense in terms of the picture. Okay. So for any quadratic function, you can use this. And you have the axis of symmetry. Plug that x coordinate into the function to get your y coordinate for the axis of symmetry. Now you know your horizontal and vertical shifts. Okay. Then plug x equals 0 into the function. Like I said, if you plug x equals 0 in here, you're going to get y equals 86, which is way up there. I can hardly jump that high. One leg, two legs is easy. Okay. But I got a bad news. I have to jump with one leg. I can barely slam dunk. It's terrible. Good heavens. Okay, so anyway, you got these points, and you can sketch them around. Like this. Like this. I have the shape of a parabola. It's got a vertex here. It's got to go through this point. Now, what you get when you do that is, I have trouble reading that. It says zeros, and in parentheses, the x-intercepts. The words refer to different things. The zeros are just the numbers that give you 0. The x-intercepts are the corresponding points in the graph. Okay, so there, if you know one, you know the other. According to it, if you don't have the graph, all you want to know is when this thing is 0, you just plug it into the quadratic formula and you get your zeros. Okay, now we're going to talk about the quadratic formula. Okay, so does that make sense? Now, if you sketch this from the information you get from this analysis, you can estimate where your zeros ought to be. And guess what? I'm going to ask you to do this. This is going to be in the test. Okay. And maybe a little bit extra. I still don't know when I'm going to schedule the test. I got to stop and think about where everybody is with their access and everything. What would be reasonable, but I'm thinking next week. Tuesday and Tuesday, which gives you 2 weekends. But I'm gonna have to include at least, that's do good in this assignment and opt in, do whatever is necessary to learn it well. So don't email me questions if you have them. It's gonna be iffy for me to do the level of comments that I present doing because I do those at home. Okay, there are things that I have to do on campus and things that I do at home because I have a better setup there for plowing through a bunch of homework. Okay, and I don't know when I'll have to I might not even read the semester. So I'm gonna have to figure out what to do about that. I'll leave it. So, if you're having trouble and you really need me to give you some comments, email me and ask. And I'll do it. Okay, you know, whatever it takes. All right. Not very convenient for me to do it, but sure, my job. Doesn't have to be convenient, does it? And I want to do it for you. Okay. But I don't want to do it for you if you're never going to look at it. So at least take the time to email me and ask. I did put extensive comments. It's kind of the last thing I did before. Yeah, this same days I was doing all the videos. I did that on the last assignment that you had. I forget what it was due. But you have comments. Sure extensive. Okay, so anyhow, you got zeros, you got your x-intercepts. Okay, let's talk about how you get your x-intercepts. You only got two, but you can use the these one video and see more details. Okay, so again, let's say we got y equals 2x squared plus 18x minus 15. Well, a equals 2, b equals 18, c equals negative 15. The action of symmetry. You get to where you can do this just as quickly as I do. Same every time. Action of symmetry, x equals negative b over 2a, which is negative 18 over 2 times 2, which is 4.5, negative signs are. It's a variable, I remember one. Okay, now, x is negative 4.5. So right away, we can start to sketch the graph. Here's x equals negative 4.5. I don't have to mark a scale on this graph to declare that this is where x equals negative 4.5. Now, for any other x value, it has to fit the scale that I've imposed. Okay. Y quarter of the vertex. Now I'm going to say this is y equals, I'll use the same. I don't want to use FP, I don't want to use H because it's used with the horizontal shift. I'm going to use S of X, okay? Y quarter of the vertex is S of negative 4.5. Because the vertex lies in this vertical line, X has to be negative 4.5 at the vertex. Well, you plug in S equals negative 4.5, fly in the world if I choose numbers, maybe a fraction, but 18 times 4.5 is 81. X squared is 20.25, which turns out is 40.5. 40.5 81 is 126.5 minus 5. Maybe. If that's right, it's kind of perfect. I have it at lunch. Okay, so you have that. So the vertex is at, if I did my calculations correct. So here's where y equals 111 4.5 on this horizontal line here, here's the vertex. Y-intercept. Okay, this is getting to be a pain. Y-intercept is negative 15. So how can that be? It's negative 4.5 and it's negative 72. It's 144 less than that. That makes it negative 32.5. Okay. So I pretended to make a mistake. Okay, here's what I want you to see is this is what we get when we plug this x into the function. That gives the point on the graph. And there's our vertex. Now I knew that something was wrong here. First, that number didn't seem to make sense to me, but I accepted it because I couldn't see that I had a negative there, even though I put it there by now. Okay. Now, y-intercept. Is 0, negative 15. So right here is 0, negative 15. And now I can draw a parabola, try to make it symmetric, and I can estimate my zeros. Okay, so we did this, and we're over time here, so I'm not going to keep you much longer. And if you got to go, you know, look at the video, which I hope is still recording. Okay, so we've constructed a graph that represents this function and shows them zeros. Now, I hope everybody recognizes this, even if you didn't remember it. It's a quadratic formula, and that's the meaning of the quadratic formula. It tells you where the zeros are. Okay, well, this equals negative 18 plus or minus square root of 18 squared minus 4 times 2 times negative 15. All that divided by 2 times 2, which is negative 18 plus or minus square root of 324, and this is 120, so it's 400 and yeah, square 444 is very close to 22. It's approximately this over 4, which equals negative 18 plus 22 over 4, or negative 18 minus 22 over 4. That's going to be 1 or negative 10. Okay, does that make sense in terms of the graph? Well, if this is negative 4.5, it makes sense that that's 1. Yeah, we might have even estimated, and we want to do an estimate. Draw the picture, make an estimate, and then see if it agrees with what you get. So this distance would be 5, and this distance, something a little bit wrong there. You go 5 to the left of this, you get negative 9.5, not negative 10. So I did some bone that thing, but I was close. Okay. I don't know how that happened. I probably did some. And there it is. And the last thing I want to tell you is, how do you get the vertex? Negative b over 2a. Right there in the quadratic formula, it's not something separate. Negative b over 2a is halfway between negative b plus this thing over 2a and negative b minus this thing over 2a. Ponder that statement. So it makes sense to you if you want to really understand. Because it ensures you that here's your axis of symmetry of this, and your zeros are equal distances on either side to the distances we can find. This is what I'm going to divide by 2. Okay. Again, that's a pretty complete synopsis. I had to go fast because we're trying to recover from a disaster. Do a lot of work so we don't have another disaster. You know, if it's at all possible, your lives might be pretty well upended by the whole situation. And if that happens, let me know. Give me some extra time if you need it. Okay. Now, let me stop the video before everybody walks out.